Hello students, welcome back. Previously we completed relations and we went through domains and ranges of relations. Finally, let's begin discussing functions. A function is a special relation where each x in the domain is related to one and only one y in the range. Want to see an example? Oh, don't pay too much attention to this symbolic expression. It's perfectly written, but it actually exceeds college algebra level. So let's go ahead and look at some examples here. Okay, how about this one here? It's a relation, yes. We have ordered pairs. Dark roast $1, light roast $1, coffee mocha $3, cappuccino $3. Is it a function? Yes, it is. For each item in the x-coordinate, we have only one y-coordinate assigned. Dark roast $1, no other price tag. Light roast $1, no other price tag, no conflict. Coffee mocha $3, cappuccino $3. That's okay. It's okay to share same dollar amount for different menu items. You see that frequently. It is a function. How about this? Cheese melt $1, nacho supreme $2, bacon double $3, Happy Meal $5. Again, no problem. I mean, it's a valued menu board. Okay, the price is ridiculously low compared with today's values, but well, that's because it was copied from older textbook. Again, this is a valid function. How about this one here? Standard oil change $30, high mileage $40, full synthetic $50, full synthetic $60. Oh, we have a problem. Full synthetic, which is right, $50 or $60. You see, this is not a valid price tag. You cannot have two different price for the same item here. So if you remove this, then it's okay. It's a function now. But previously it was there, so this is not a function. So same x-coordinate, full synthetic, is assigned to more than one y-coordinate. $50, $60. So that's not a function. Another way to express the function is to use arrows. Again, let's not pay too much attention to these symbolic expressions. This thing exceeds the college algebra level, but we can understand it through examples. Cheeseburger $1, McChicken $1, bacon double $2, and so on. Yeah, this is a valid price tag. More than one items can share the same price, but that's okay. Each item has a one and only $1 amount. This is a function too, but this is one-to-one function, a little bit special. So I can come back as well. Now, how about this? This is not a function. Gas station days, the life expectancy, all right, whatever it is. 240 is assigned to 12 or 20, which is right. That's not a function. So we can use pair expression, or you can use arrow expression, or you can use algebraic expression, and I'll show you a little bit more about the algebraic expression in example problems here like these. So all these are ways to explain a function. Pair expression, that's okay too. Arrow expression, that's okay too. Algebraic expression, that's okay too. Most of the time here we'll use algebraic expression. That's because we are doing STEM algebra. Okay? Alright, let's do some example problem based upon algebraic expression of a function. F of x is defined as 2x squared minus 3x, and then evaluating the following quantities. So the value of 3 under this function f, or the function value all I have to do is substitute 3 in place of x here. So what do you have here? F of, now let's copy paste this thing, just go ahead directly. Here I'm replacing x by 3, so I have to do the same thing for all of those. And calculating this, that shouldn't be too bad. 9 times 2, so 18 minus 9. Did I do this right? Yeah, that's 9. Well, here's the next example. Substitute -1 in there and do your computation. You're going to get 5. And then this expression, okay, this thing is called difference quotient or Newton quotient. So f of 3 minus f of -1 over 3 minus of -1. Well, nothing more than just substitution again. 9 minus 5, that goes to the numerator, and denominator 3 minus of -1 is 4, so 4 over 4 we get 1. What do you think? That was easy. Alright, finding out some values, that was easy. How about doing some symbolic computation? F of -x versus negative of f of x. Okay, alright, let's go ahead and do that. F of x is 2x squared minus 3x, isn't it? So if you put negative there, then you have to replace all the x's by negative. Can you simplify this? Let's see, 2 times negative squared, so negative goes away, and then negative, negative, positive. Looks like that's what we get. How about negative of f of x? That's negative of, what is f of x? 2x squared minus 3x. So distributing this negative sign, we have negative 2x oops, wrong key, plus 3x. They're not the same. I can always pull negative outside. What did I do in my answer key? Yeah, the same thing. They're different. Okay, one more. It's similar to this. This thing is called difference quotient or Newton quotient. Let me expand the font. Okay, alright. Let's copy and paste this thing. And then in place of this first parenthesis, I have to get the second one is easier, so let's do this one first. F of x goes here. So this f of x, which I just highlighted in purple, becomes this thing. I guess even bigger font is helpful. Now let's do the same thing for this one here. Let me highlight this in blue. Okay, alright. So we have to have this 2x squared minus x, but in place of x, I have to put x plus h in there, and I have to put x plus h in there. Let's see, we have the correct quantity. Is it necessary to simplify this? I didn't say anything about simplification in this particular problem, but if you encounter a problem like this in MyMathLab, yes, there are problems like this in MyMathLab. Excuse me, are we using Cengage or Pearson? I'm not so sure, or whatever we are using. This kind of problems do appear there because this is important. Whenever you see any kind of name attached to anything, it's important. This is called Newton quotient. You don't have to remember the name Newton. Just remember that this was attached to a certain name, which means it's important. So it'll appear in all kind of homework tools. In that case, you'll have to simplify. This very problem did not say anything about simplification, but most of the time you do. You can simplify like this. Let me expand the font so that, maybe even further, so that you can read. So substitute x plus h in place of all the x, and this is complete square, so FOIL out, and distribute is -3, and then distribute this negative sign, and then distribute 2, and everything is positive here, so you lose all the brackets, and then take some like terms. If you do that, you're gonna get all the h's coming up here, so you can factor h out and then h downstairs. After simplifying, you get a polynomial expression, no more denominator. I admit it's a difficult computation, but there's a reason this kind of thing is emphasized, so we'll do a little bit of this. I'm not going to overdo it, but a little bit of it will do it. And yes, I assign those kind of problems in the computer drills. Pearson's MyMathLab. Let's see, do we have enough time for algebra function problems? Okay, let's try to squeeze in. F plus g is just adding up the function value. F minus g is adding up the function value. Multiply, divide, etc., etc. You can go ahead and do all those. For example, add these. You have nothing more than adding, these two. So just add these two. Simple, isn't it? Subtraction, f minus g of x, is just a subtraction. Clear, isn't it? Just subtraction. Now multiplication, multiplication. Is that clear to you? Multiply the numerators and multiply the denominators. And I don't really want to break up the parentheses, but if you're asked to break up, then you have to fold each, and you're going to get a quadratic over quadratic expression. Personally, I prefer to keep those factored forms. You'll see later, factored forms are more useful most of the time. Finally, division. This may be a bit worthy, because dividing means multiplying the reciprocal. So 2x plus 3, 4x minus 5 are the same, but 4x minus 2, 5x plus 3, we took the reciprocal. So denominator became numerator, numerator became denominator. That's it for algebra of functions. Simple. So only the definition of the function was hard. As for computational stuff, no big deal.